Awesome. Fine. Welcome everyone to Geek Night. This is the 71st edition of ThoughtWorks Hyderabad Geek Night, and we have Pratitva with us, who is a senior thought worker in ThoughtWorks, and he's been pretty much interested in blockchain and other techs. So he wanted to give a topic on today on blockchain and how to get started with the blockchain. So I'll hand it over to Pratitva. Over to you all. Pratitva, enjoy.
Sure.
Bye.
Hi, thanks, Arup. Hi, everyone. Just a little disclaimer about me. So I'm not a techie, not a full mentor in blockchain or anything such. I have started reading about blockchain for over an year now, and through multiple videos, reading materials, and everything, I just realized that wow, it's a very complicated technology, and it needs to be streamlined. So I started writing about it, and in the process, I realized that I can explain it a little bit simpler, a little bit more relatable to the everyday things that we do. Much closer to, and I also realized, when you hear the term blockchain, it completely blows up your mind because it's a very fresh or new technology, and before anyone could anticipate what it does, multiple applications of it came across, and it just blew everyone's mind. So in this session, I'll try to keep it very simple. If you are in field of computer science, it would be even easier for you to understand. I will try to use less and less jargons related to computer science, but wherever it is required, I will have to. But just in case it's not coming to you, and if just in case you are not able to understand, please stop me. We can use much more human examples. Okay. All right. So let me just get started first with what do I have for you in this meeting. So very quickly, we will do a brief of blockchain, something like what is actually blockchain, what is the difference between blockchain and blockchain as a technology, a little bit of history, and where do or how the modern applications are finding blockchain and utilizing it. It will be a very brief session. Then we will dive into our main content, that is blockchain architecture. So the entire session is divided into two parts. One is blockchain architecture and another one is blockchain technology. So first thing that you need to understand about blockchain is it's a record, or it's a data management system with a very hardcore security. So whenever when we are discussing blockchain, we will be discussing about its security, that what keeps blockchain so secure. So when I say blockchain architecture, I want to first tell you that blockchain architecture is its first line of defense. Like, what is the first thing that keeps the blockchain secure? Secondly, then we'll move to blockchain technology, that is their internal functions. Like, what is its second line of defense? What are the internal components of blockchain that it keeps it so secure? The interesting thing about this session is that I have planned two demo for you. One is related to key encryption, to give a trailer of it. So I will be showing you how public and private key is being used inside blockchain architecture to keep it secure, or to avoid or to resist any change in the data. Second one, in the last, we will do a demo of data mining. So in this, I will role play a hacker who's trying to crack into a blockchain, and how blockchain is trying to resist that change. And even after I have overcome that resistance, anyone who owns that blockchain will still be able to recognize where was the hacking done and what are the impacted areas of it. Okay. Uh, Moving further, just a brief of what we are not going to cover in this session is, first, that this is not a programming session for blockchain. I won't be able to tell you how you can become a programmer for a blockchain, or in which languages a blockchain is totally written and all that. Possibly not. We won't be able to cover this in this session. Another thing, we won't be going after the applications of blockchain, that is cryptocurrency and NFT. So we won't be discussing that how Bitcoin works, how Ethereum works, and what is NFT. All these things, maybe we'll reserve it for some later sessions. So if everyone is good, we can get started. All right. So starting with the very basics, what is blockchain? So blockchain, though it's out there, it's being called the revolutionary technology and big adjectives. It is nothing more than a record keeping system. In fact, it is a very glorified, a very sophisticated record keeping system. Before I explain it to you that why do I use the word glorified, let me just explain it to you what a record keeping system is. Imagine you have a ledger. You are maintaining a physical copy of a register where you are marking down all the transactions of your day. Like you sold lemonades for 5 rupees to this person, so and so. Imagine this ledger is being time stamped. Like every time you are making an entry into that register, there is someone who is noting down that at this time, this register was opened and this entry was marked down. Same time, whatever you are writing in that register is only understandable by you. So you're not writing in this thing in some plain English. You are writing this in some cryptic language that only you and some other people can understand. Third thing, you have created multiple copies of this ledger, hundreds and billion copies of this ledger, and you have spread it across the world anonymously. So no one knows how many people have a copy of your register, of your records. They just know that there are multiple copies of it. What you have done right now is have imagined or created a similar physical concept of how blockchain works. Okay, keeping this in mind, let me first break the myth or just ease you down with what is the difference between blockchain and a blockchain as a technology. When I say what I described to you right now with a physical ledger or register is a blockchain technology. This blockchain technology could be implemented to any software or any record management tool. So for now, I related a blockchain technology to a physical register. We could relate this technology to any type of transaction, whether it is digital, whether it is physical, if it is happening in these three type of if it satisfies these three conditions, that is it is cryptic, it is distributed across the world, and it is being timestamped, then we can successfully call it as blockchain technology. Now, what is blockchain? So blockchain is basically like a tool or a software. So it's a generic term given to any application. A closest example for you to imagine would be the Linux console or a command prompt. So like you click on Microsoft Word to open Microsoft Word, you just log into the Linux console or you just log in into command prompt, give in your username and password, and you can enter inside a blockchain. It's that simple. What happens inside it, what is different between a Linux console, a directory, and a blockchain will look a little further. But for now, just to ease you down, just remember, it's just an application. It's just a tool, nothing more. Then covering a little bit of history. So blockchain, although it's gaining the fame and this big hype right now, it was actually founded in 1991. Around 1998, it credit card companies or credit management banks actually tried to use this technology, but they overruled it. They thought that this is not going to work. It was in 2008 or 2009 that an unknown person created the first application of blockchain by making a very small difference in it. First of all, when in 1991, when blockchain was first discovered, it was said that it will be a cryptic transaction record. There was no concept of having it distributed across the world. There was no concept of that we won't know, like there was no concept of that there will be multiple copies of a transaction which won't be password protected. The only way to ensure that this record, this particular transaction is correct, is to have multiple people saying the same thing. When this change was implemented in 2008 or 2009, it was called Bitcoin. Okay, and that is how when blockchain actually found its application or actually found the fame or the hype that we are looking after or that we are observing today. So basically, this is all a little bit of blockchain history and type of blockchain that you need to understand. Our session is mainly about to understand blockchain, two line of defense. First one being architecture. But before I dive into the architecture, let me explain it to you that why did I use the word glorified? So I already explained it to you that any record keeping system who has a timestamp can be classified as a blockchain. Another thing it needs to that separates your register or your encryption with a sophisticated blockchain technology is that it uses hash function. We'll talk about hash function a little later. Just to give you a little idea, it's an encryption. It's an encryption. It's an encapsulation. So not in. So what it does is that any form of data, any form of record that you pass through an hash function, it will convert that into a bit size of 32 bit size of data. So it's basically a representation. You cannot decrypt this 32 bit size of data into your original file, because your original file could be an image, it could be a date transaction records of some 2-3 GBs of data. You cannot. Another one, or the third thing is that makes a blockchain record glorified record keeping system is it has a decentralized network, that is the entire transaction record is distributed unknowingly to the entire world. But one important thing is that it's a peer-to-peer. That is, every person who is having this record will have equal rights, equal power to change this record. The only difference is that for this change to stick, at least 50% of total people who are having this record should agree to this change. These four components make blockchain a glorified record keeping system. So I know, I understand that right now it's not making a lot of sense. It's all up in the air, but this is just a general theory. We will start now slowly, look after every statement that I have given to you and look it into detail. We'll try to validate why am I saying to this. So first let's look at the architecture of blockchain.
Before jumping in, there's a question which Satya has been asking, that is blockchain a database?
Yes.
So I think yes, Satya. So Pratitva is saying that blockchain is a database, and I hope it has answered your question.
So Satya, just to add to your point, blockchain is a database, but comparing it with any SQL databases, that you can change an SQL database very easily. There are options to track which user ID did this change and everything, but there are not many options to resist that change. An SQL server cannot automatically decide, you know what, this change is not correct, I should revert it. That is what makes a normal database different from a blockchain architecture or a blockchain database. We'll look it further. You'll get to know how it is different. Okay. Now, coming back to blockchain architecture, or as I like to call it, the first line of defense. So in blockchain architecture, there are three things that you need to understand. That is data blocks, network topology, and the use of public key and private key encryption. Let's first look at data blocks. Okay, so remember when I told you that like blockchain is an application, it's just simply a tool. Imagine that you have opened that application and all you can see is some data blocks. These data blocks are nothing but a partition inside your hard drive. For example, you have 50 GB of hard drive. You have partitioned that hard drive into 1 GB of data blocks, just spaces, digital spaces. Now these digital spaces contains three things. One, obviously the data that you want to put inside them, that is the content which you want to secure. Second thing, it contains the address of the previous block. So it's like an inverted linked list. Okay, the entire 50 GB of data, so that entire 50 GB of hard drive, which is partitioned into 50 pieces, each of the 50 piece is having the address of the block which is previous to them. Exactly like how a linked list looks like, or how you can see in this particular diagram that block 2 has the address of block 1, block 3 has the address of block 2. Similarly, it contains some metadata or properties of the block. When I say properties of the block, it will be a little difficult for you to right now understand because advanced concept which will be coming further. But just for the sake of telling you, it contains some puzzles, some logic, which tells you whether or not this particular data block is valid or not, whether this particular data block belongs in this blockchain or not. We'll see further how these properties are helping to keep things secure. But for now, I think this much information is fine. From this slide, you only thing that you need to understand is that each data block contains the address of their previous data block, and it's not a live copy. It is static. So once I've created this blockchain, once I've created these blocks in a sequential form, and I have entered the address of block 1 in block 2, I would, and the address of block 1 changes, it does not mean that block 2, the address will change automatically. It won't. It's just the block 1 will become abandoned. It will become an orphan. Okay. Second thing that you need to understand about is network topology. So we have been discussing about it for some time now. Blockchain, what makes blockchain is its decentralized network. The 50 GB partition that you have created, the architecture or the arrangement of each partition, 50 GB partition that you have created is copied across multiple computers across the world. No one knows all these computers. We just know that there must be some 1,000 or 10,000 computers which are having the copy of this exact architecture in their computer. Not necessarily if my laptop will have only architecture or data, blockchain of only one company. I could be if I have a space of, let's say, 500 GB in my computer, I can be hosting a blockchain of 5 or 10 multiple blockchains. Not necessarily that only a dedicated system is required. Okay, so what makes it from this slide, the main thing that you need to understand about is it's a decentralized network. Decentralized because if change is being made into one computer, if change is made into 2, 3, if say out of 1,000 only 100 computers are impacted, let's say by a hacker or a natural calamity, the data does not get impacted because other 900 computers are still having the same copy, and they can overrule or they can overwrite any change that has been made by an unauthorized person, or any change that they see is not in their own system. Another thing that you need to take away from this slide is that in a blockchain, irrespective of who owns it or whether it's public or private, the basic rule is 50% of the peers. When I say peers, if a blockchain has 10,000 computers in a network, at least 5,000 of them should agree to a change for that change to stick. These two components, the decentralized network and the law of 50% of the peers must agree for a change to stick, makes blockchain a little bit more secure for a hacker, from a hacker or a natural calamity. Now coming to the most important part from a blockchain architecture is public and private key encryption. In case, for those who are not familiar with, the public and private key relation, let me just explain it to you. So private key could be any string of numbers that you imagine, for example, or it's basically like a password that you imagine and you need not, or you do not share it with anyone. For me, I have imagined my private key to be 1, 2, 3, 4, 5. There are already systems and logics in place which generates a public key for a particular private key. I'll demo it to you that how this relationship works. But for now, just imagine just understand that given the size of my private key, a particular size of public key will be generated. Now, public key is only a representation of the private key. It's not a encryption. Okay. The only thing public key can do is that it can verify that whether it is related to a private key or not. I know if you are not aware with the public key and private key encryption right now, you won't be understanding. We won't be able to understand it. So let me just quickly move into a demo. But before that, let me just take up some questions. Satya, you are asking, is it like some web application running live through some servers? In a way, yes. So, for example, just imagine a software, or just imagine a Gmail account. A Gmail account where you have your noise groups. Each noise groups represent a blockchain. What happens is that you get a message over there from the owner of that particular noise group. For example, IBM is the owner of that blockchain. You are just one of the peer. You get a message that, hey, enter this transaction into my blockchain. The first thing you do is validate whether this message is correct or not. Okay, I'll show you that how do you do that validation. But right now, I think it explains to you that yes, it's some sort of web application. Another one is, can see change data capture is implicit, but not sure how different the feature in blockchain. Vijay, I'm not really sure what you're trying to ask here. So I'll take the next one. Who decides the system part of this network? Okay, so let me answer to you this in this way. So blockchain are of two types, private and public. If it's a private blockchain, that means it is owned by a company and it is hosting their blockchain to other counterparties. Like, for example, ThoughtWorks has a blockchain. They have invested in the architecture. They have created this entire system. Now I come to ThoughtWorks and I say, hey, you know what? I have this college and I want to put in the results or the degrees of my students in your blockchain. Can you do it for me? So this is how, like, one way the architecture or the system or who will participate in the blockchain, the peers in the blockchain is decided by the private owner. But when it's a public blockchain, it's open to everyone. Anyone can join it. Some blockchains have restrictions or some preconditions, like your computer should have this much RAM, your computer should have this much processing power. Unless and if not, then they don't even let you join that blockchain. Usually there is a lot for a popular blockchains like Bitcoin. Bitcoin is just basically a blockchain only. There is a long list of peers who want to join that network, because unless and until you join that network, you won't be able to mine it. If you won't be able to mine it, you won't be able to earn a Bitcoin on your own. You'll have to buy it on some trading website, spending your money. So can we create our own blockchain like Bitcoin, right? Yes, you can. And this is what is happening right now. So that Doge, Bitcoin, and other fancy names, all these people are just creating a bit like a blockchain of their own, and they are selling cryptocurrency via marketing. Do all nodes in the network should have the whole chain? I mean, if there is a 50 GB of data, then all the nodes in the network should have 50 GB data. Yes, this is very important. All the nodes in the network will have the exact same copy of the entire blockchain. Is there any other application that Bitcoins that use blockchain? Right now, blockchain has only two known applications. One is cryptocurrency, another one is NFT, non-fungible tokens. I think even the certificates, this COVID vaccine certificates are now being published via blockchain, but it didn't really took off. Like some people who were, some hospitals who were providing vaccines started using blockchain to upload their certificates, but I'm not really sure if that really took over. What are the incentives of joining any blockchain? I mean, why would anyone join? So imagine it like that. So you do know that Bitcoin is a blockchain. So when you are allowed to join that blockchain, you are one of the peers. And whenever there is a request of, hey, can you enter this data in that blockchain? This entire process is called mining. So when you are successfully able to enter that data in that particular blockchain, you are being rewarded by the cryptocurrency. Or you can, and or to make it more generic, every blockchain has an incentive program. So whenever, and the incentive is always given when you enter some data into the blockchain, or when you create a new data in the block, that for that particular incentive you join that blockchain. Who decides the standardization of this technology? So no one decides the standardization of this technology. It's just in 1991, whosoever was the founder of this technology created this format. Like, this is how it will work. This is like, instead of password protecting your data, why don't you just let it out in the open, create multiple billion copies of it, and and those multiple copies will let alone defend any change. So that is how this technology, this standardized way of protecting data was created.
Pratitva, I think the Vijay has a question, right? So possibly he's just saying that so the capture data change, right? It's more of a feature like the auditing purpose. It's similar to blockchain, is it?
Just when every change is captured and who has done persistent for audit purpose. So it's more than an audit purpose. Imagine it like that. So in an SQL database, everyone logs in there using their own user ID. So when you go and make a change in that table, uh, the record will show or reflect that this particular user ID did this change. This is where the auditing purpose ends. Blockchain is further more than that. It is an intelligent system who would be able to tell that who will be first able to identify this change was done, who did it, when they did it, and if no one attends to that, after a week or a periodic time, usually it's 1 week, it will be able to revert that change also without any human intervention. We'll look in the further demos, you'll be able to understand how it is able to identify and revert that change. Okay, one last question. Is buying a cryptocurrency means joining to an existing blockchain? Okay, so you use the word buying. So I would say no. When you are buying a cryptocurrency through, I'm not really sure of those portals, then you're not becoming a part of blockchain. You're just a trader. Okay. Now, let me take you to the example. All right. I hope everyone is able to see my window. All right, I'll assume this at yes. Okay. So starting with the basics first, the relationship between a private key and a public key. Okay. So like I said before, a private key could be any number, any length of string that I decide, and I keep it private to me. I keep it secure. I don't tell it to anyone. So for me, I am choosing 1, 2, 3, 4, 5, 6. And accordingly, a public key is getting generated of similar length. So the length of public key depends on how long my private key is. Right now, I'm using an existing software. There are multiple softwares out there which can create a public key in relation to the particular private key. For creating a strong private key, let me just click on random, and it has generated a public key for me. So, okay, this is a simple part. Let me take you to a more understandable part. Okay. So this is much more of a realistic scenario. Let's role play that I am an owner of the company and I want to send a message to a private blockchain. Let's say ThoughtWorks is the owner of that private blockchain, and I want to tell ThoughtWorks, you know what, just make an entry in the data block with this message. Now this message will be sent across all the 1,000 peers who are in that private blockchain. But before that message gets sent to them, what I do is that I've written down my message. I am entering my private key, which is known only to me, and I click on sign. When I click on sign, a new component is generated. It's called signature. So signature, again, this is not an encryption of the message and private key. This is basically just a representation. It only tells whether this private key is related to this message or not. Okay, much more realistic. When I am sending a message in the noise group of ThoughtWorks, I will tell them this is the message. Very openly, I will tell them this is the message that I want to enter in the your private blockchain, and here is my signature. Only these two information I will share with all the peers who are part of that private blockchain. What they will do is they will use my public key. Now, public key is something that I need not to keep secure. I can just openly broadcast it because, like I told you, it's not an encryption. No one can decrypt my private key using a public key. It's just a representation. So assuming all the peers in that private network, in that private blockchain network have my public key, what they will do is they'll use this public key to verify whether this signature and this message are relatable or not. Basically, whether this signature was created using my private key or not. So an example would be when they click on verify. When I click on verify, it basically it's green. It is suggesting that this particular signature does belong to this message, and also this particular signature was signed by a private key related to this public key. To give an example, that if I go ahead and make a change in this message and I try to verify, if I make a change in this message and I still try to verify, this does not pass because this signature is not validating. This signature is not able to relate to this particular message. It only knows that this was the message for which this signature was created. Anything new, any change in that, this signature does not recognize it. Another tampering that can be done is that if you are using a wrong public key or a public key which is not related to my private key or a public key which is not generated by my private key, and I try to verify it, it will again not verify. So this is how a peer in a entire blockchain network decides or verifies whether the message that is being sent to them is correct, valid or not. Okay. Let's have a much more realistic example of how does it look like inside a blockchain. Okay. So this is a transaction screen. Okay. What I am doing here is I want to show a transaction. I want ThoughtWorks to enter a transaction in their private blockchain for me. And I am sending them this message that I have transferred this $200 from my public key to any random public key. So again, like I told you before, public key is public. It is known to all. So it can be also an address. It can also be a name. Just for the understanding purpose, I am keeping it logical here, and I am making my transaction look like that I am transferring $200 from my public key, which is known to everyone, to let's say Aroop's public key, which is also known to everyone, and everyone knows that this public key belongs to Aroop. And then I enter my private key, which is known only to me, and I sign it. Okay, so this particular signature is generated. What will the peers in the blockchain do is that they will take up this signature, they will take up this transaction record, and they'll verify whether it checks out or not. So they'll verify that whether this public key and this public key and the transaction are related to the signature or not. If this signature says that, you know what, this is not the message that I was representing, if I do even a slightest change in there, and try to verify it, it will catch it. Okay. Let's look at it in much more realistic way, and how does it look like inside a blockchain, or like how a blockchain is able to identify a change or resist a change using public key encryption. So right now, okay, before I get there, just a quick recap. So this is a representation of data blocks in a blockchain. Block 1, block 2, block 3, block 4, similarly. Okay. As you can see that this is the address of first block, and the second block is storing the address of previous of their previous block. Similarly, the third block is containing the address of their previous block. For okay, now coming to our public and private key encryption. Okay, so this is block number 5. Here I have stored one transaction that I have transferred, or someone has with this public key has transferred $7 to this public key, and this was the signature of that transaction, which guarantees that whatever information is published here is correct. Now, let's assume I am a hacker. I hacked into this blockchain and I directly went into block number 5, and I alter this transaction. I say instead of $7, $7,000 were transferred. So two things happened here. One thing, like I told you before, that blockchain or a data block contains 3 things: data, the encryption, and timestamp. So right now we just need to focus on data and the encryption. So data is altered. The entire data block is invalid because the hash address or the address of this data block has changed. And we'll look further that why this hash address is changed, and when it is changed, why it is a bad thing. Okay, well, we'll look further upon it, that how is it a bad thing. But for now, just for the sake of understanding, let's assume I am a very capable hacker, and I have guessed what will be the next, or what will be a valid hash address for this particular block, and I have calculated it and I have updated it, which validates this block again. It is now again a part of this blockchain. But what I couldn't do is validate this signature. What I couldn't do is improvise on this signature, because I don't have private key of this public key or this public key. Basically, I don't have the private key, corresponding private key of this public key, which means I cannot update the signature. I can never guess that what was the, basically I cannot change the signature or validate the signature because I don't know the private key. If I knew the private key of this particular public key, I would generate the same message again. I'll go back to the transaction. I will say, I'll generate a new record of $7,000. I'll enter my public key here, and I'll enter someone else's public key here, whosoever I want to transfer this data. And since I am a capable hacker, I know that I have hacked the private key as well. I'll sign it with that private key, and I'll get the new signature, which I will copy it here when I've updated this transaction records to 7,000. But since I do not have the private key, even though I validate this block, this signature will always keep on telling, will always keep on pointing that, there is something wrong here. And this is how a blockchain is different from an SQL server. So in an SQL, similar to an SQL server. So just like how an SQL server is able to tell you that this particular user ID did the change in this table, in this column, blockchain private key and public key encryption is able to tell you that this particular transaction record is being impacted or is invalid. This is important here because usually in a blockchain there is tons and GBs of data, and usually these are just transactions, small transactions. So pointing out one small change or one invalid change is like finding a needle in the haystack, which makes blockchain a little bit more special than an SQL server. Okay. So this is all there is to know about blockchain architecture or its first line of defense. I want to pause here and take question and answers or any doubts anyone is having.
Yeah, there are a couple of questions actually.
Okay, so one is from Kushbu. Kushbu wants to know that can private network read message? Yes, private network can read the message. In fact, public network can also read the message. In fact, anyone who is part of that blockchain or not part of the blockchain can read that message. Redundancy.
So, Pratit, just a follow-up question on that. Does that mean anybody can see that blockchain? That means it's publicly available. It's just that who is owning it? That's a question over there. Or if anybody wants to change it, then only blockchain is helping us.
Correct.
That you need to have 50% peers and all that.
Correct.
Cool.
Okay. Vijay wants to know redundancy of message is possible. Not really sure. Are you suggesting that the person who is triggering the message will be able to send the same message again and again, or multiple people can try and enter the same record again? So I think your question is on the second part, that multiple peers will make an attempt to enter that record into the blockchain. Yes, that is a possibility, but to overcome that possibility, we have to look at the second line of defense. That is where the mining comes into the picture. We'll cover it. Your answer will get, your question will get answered in the next part, that how not everyone is able to make an entry inside the blockchain. Okay, one question from Vignesh. All the blocks in the chain will be of same size? Yes, like I told you. All the blocks in the chain will be in the same size. Not necessary. It depends on who also ever created that architecture. Most of the private networks keep their first block heavy, and all the subsequent blocks which are created are lighter. This is because if your most of the data, or because if your most important data is in the first block, that means if this is my first block and if I go about make a change here, all the other blocks which are pointing to this block will become invalid, because all of a sudden when I make a change any change in this block, the hash address of this block became invalid, and all of a sudden this block number 2 does not have a parent. This block number 2 does not know who it is pointing to, and if this one does not know who is it pointing to, this one also does not know who is it pointing to. Similarly, the entire blockchain becomes invalid. That's why some of them try to keep it that way. Okay, one question from Satya. Any storage issues on the network since every record is a copy? Every record. So blockchain, I haven't heard any storage issues on the network as such. There are problems of like network congestion, especially in case when okay, let me take an example of Bitcoin. So Bitcoin has around 3 lakh peers last I checked, and every day they get for like 2,000 more number of requests to join that blockchain. So that creates a network congestion. And what happens is when there is a request of making an entry into the blockchain and everyone is trying to solve the puzzle or do whatever is required to gain the right, only one person will get the right to make an entry into that blockchain. So it's like lot many pings, lot many requests are coming to one particular server. So that creates a network congestion. So yeah, there is a limit. Is there any limit on how many transactions each block can hold? It depends on its size of the block. And it's not necessarily that it can store any amount, anything, any data as such. But right now, since cryptocurrency is one of its popular application, we talk in terms of transaction. Does all private and public blockchain network are interconnected by default? Yes. So not private blockchains are not connected to the public blockchain, but blockchain as a concept says that all the computers, all the peers need to be interconnected. It's not even interconnected, they are just hosted on a same network. They're just connected by a label. So like how all are, we all are thought workers. Similarly, everyone who is on Bitcoin blockchain is connected by the label Bitcoin. They can be part of Shiba blockchain as well using the same computer. It's that easy. You just have to close a window, open a window. Can the private key be hacked? If so, then can we alter the data in the block and make it valid? If private key can be hacked, yes. But generally, it is very difficult to, like, it's one of the strongest algorithms that we have between private key and public key. But in just in case, if a private key is hacked, then yes, it makes it very difficult. It makes hackers' job very easy to break the first line of defense and alter this particular transaction and make it valid. But that is when the second line of defense comes into the picture. So right now I was able to click on a button and validate this entire block. Generally, it's not that easy. We'll discuss this in the next thing that we are going to discuss, that why this block became invalid and what all things are required to make this block valid again. So there is no, so last question from Khushbu. So there is no privacy in blockchain. It's good for situation where we are more concerned about the mutation of data. Exactly. Yes, Khushbu. Generally, when it comes to privacy, people who are concerned about privacy for like private companies, they go hire a private blockchain where their data will not be visible to the public. But for other applications, especially cryptocurrencies, they are hosted on a public blockchain where they do want people to be able to see the transactions that is happening. Okay. Now, coming back to our presentation. I'm not sure, but I'll share this presentation with the host. I have shared three kind of things with you. One is the blog, which contains all that we have discussed so far, a video of me telling you how exactly this thing works in a much more precise and better way. And the example that I was showing you, that entire 4 or 5 thing tabs of how public key and private key encryption works, that tool, a link to that tool I have shared with you. So you can use it, play around and see how actually it is working. Okay. Oh, yeah. Now let's come to the more complicated part of blockchain. That is, now we are stepping inside the blockchain. Just to give you a recap so far, blockchain technology or blockchain architecture does not allow any unwanted change to stick. Like we showed, like we saw how, right? Unless and until you are able to guess the private key, the unwanted change will always be read. But now what we are going to discuss, now we are going to look at internal functions. And those internal functions will tell us that how quickly a blockchain is able to identify the impacted area and able to restore it as well. So when I say internal functions, there are 4 things that you need to know, or 4 terms that you need to know about blockchain. One is hash function. It is again a general thing that we'll discuss, not particularly always related to blockchain. It is an encryption technology that I think even many of our ThoughtWork projects, or basically when API transactions are happening and we want to cover up the password, we use a hash function. So not that like, like who hash function kind of thing. It's a normal encryption technique that is good, but used in blockchain as well. Another one, again, we will be looking at data blocks, because like you already saw in the demo that there are more to a data block than just the 3 things that we saw. So we will be looking at data blocks little bit more in detail, or basically a naked picture of data block. And third, Merkle tree. Merkle tree, you'll see when you'll understand when you see it. And fourth thing is nonce. So nonce is very important, perhaps like how private key and public key is able to defend a blockchain. Nonce is the thing that is again able to defend a blockchain by making it invalid. Whenever there is an unwanted change, nonce is the thing that makes that block invalid. Okay. Now let's look at these things in detail. So first, let's talk about hash function. So by definition, hash function is any mathematical function that can take input of any size or any type. When I say any type, it means a certificate, an image, an entire table, your entire hard drive, doesn't matter if it is in digital form. It can take it and it can chew it out into a fixed size, uh, output of 32 bits or 32 digits. So like, as you can understand from this example, there are different type of data which this particular hash function is taking in as an input, and always it is giving you a 32 digit encryption, sorry, a 32 digit representation. Now, difference between a public key and private key and a hash function is the size of public key depends on the size of private key. If my private key is of size 5, that is 5 digits, my public key will be of some particular size. Hash function, not that case. And also, in a case of private key, it has to be all numeric. In case of hash function, there is no such restriction. The data could be of any type, and the output will always be of size 32 digits. That is one thing that you need to understand about hash function. Second one, a little bit theory here. So latest hash function that we know is SHA-3. I am pretty sure that we are already using this one in ThoughtWorks and very commonly when securing password. So each hash function, so there is SHA-3, there is SHA-2, there is SHA-256 and SHA-512. Basically, each hash function has its own fixed size of output. SHA-3, which is popularly used in a blockchain, has an output of size 32 bit size or 32 digits. Another thing is hash function. Hash is not an encryption. Okay, it's again merely a representation. So when, like an example, if you are giving an image in an input to a hash function, you cannot recreate that image or you cannot decode that image just using that 32-bit key. So again, hash function is just a representation. Another thing, and this one is very important, even a slightest change in the input of a hash function will change the hash, the output that has been created completely. In the demo, I'll show you that how small of a change a hash function is able to detect, and which is why hash function is so popularly used in a blockchain. Then moving to the second part, that is looking at the data block under a microscope. So we already know that a data block contains three things: timestamp, the data that you want to protect, and some particular, like, properties of that data block. So let's look at a little bit of more detail. Like, okay, we know already that timestamp is already there. Version is a new thing. Version is basically suggesting that how many times that particular data block has been updated. So it's again a number, nothing more than that. Another thing is hash address of the previous data block. So we knew that data block contains the address of the previous block. Now we know it contains the hash address of the previous block. Now why I'm saying hash address, because the address of a data block is generated using the 5 other things that you are seeing here. So using the timestamp, version, data, nonce, and difficulty target, the address of data block is generated. So basically these 5 things are input to my hash function, and the output which I'm getting, the 32-digit string I'm getting, is the new address of that data block. So this is again stored inside the data block. Another thing is data of, like, the data, the content that you want to store inside a data block. So this data is not stored as it is. it is stored as it is, as in like we saw that there was a transaction that, like, from this public key I transferred this data to this particular public key. So although this data is visible to anyone, it is not as simple as, like, you just entered into a blockchain and you open a couple of files and in Excel sheet you see those transactions. It's a little more complicated than that. And because there is a limited size to which a data can be stored. For example, if my entire blockchain is of size 50 GB and you come and tell me that you save this 50 GB size of movie print in your blockchain, my entire blockchain is occupied. So it is stored in a form of a Merkle root. We'll see how a Merkle root works. Then there is nonce and difficulty target. So basically, these 6 things make up a data block. The important thing that you need to understand from here is the hash address, that how an address is generated, and always a data block contains the hash address of their previous data block. Here, one thing that you need to understand is I am having the hash address of previous block. So if any change is being done in whether timestamp, version, nonce, or data of the previous block, the hash address of that particular block changes, because, like, the hash function, that is how the hash function works, and making my current block invalid or an orphan. All right. Right. Okay. Now let's just look at that what exactly Merkle tree is, or how exactly data is stored inside or represented inside a blockchain, or sorry, inside a data block. So for example, I had 4 transactions that I wanted to store inside a data block. Each transactions will be hashed, or, like, will be passed through a hash function, and, like, 4 different hashes will be generated for it. And again, like, first 2 hashes will be combined, third 4 hashes will be combined, and likewise a tree would be created unless and until I have one single hash output for all the transactions, all the data that is stored in that particular block. That particular root is called Merkle root. And for the representation state, or in your first view, you will always be able to just see this Merkle root in a data block, not the data in your plain sight. Okay. All right. Then I'll continue to the second part.
So, Pratik, just a question up there. Is the Merkle root then the whole, whatever transactions are present in the block, that is the Merkle root, or it's the whole blockchain's data which is present?
No, it's just a transaction. So each block has a Merkle root.
Okay, each block has a Merkle.
Okay. Now coming to difficulty target and nonce. So I would suggest to keep your ears open, because this is perhaps the most important thing that you need to about a blockchain, and the thing which makes blockchain so interesting and so secure. Difficulty target, very simply, is basically a puzzle to give you, and now this puzzle can be as simple as that every time a hash address is generated for a data block, that hash address should start with 4 zeros. So this is my condition. Okay, now I have a data block, you make some changes in it, I don't care, but the resulting hash address of the new hash address of that data block should start with 4 zeros. This is my condition. This is my difficulty target. Okay, so this is one simple difficulty target that, like, a blockchain can adopt. Usually private blockchain keeps a, like, a bunch of, or a package of difficulty targets, and every time a new block is created, a random difficulty target has been picked and broadcast to all the peers, and they have to, like, solve. They have to, like, okay, first, just for now, just keep in mind that for our demo or for our blockchain, difficulty target is that every new hash address should start with 4 zeros. Now to achieve this, like, how do I ensure that hash address start with 4 zeros? Like, because I'm just changing the data. I'm not creating the address. So I go to nonce. Okay, nonce is again nothing but a whole digit number. It could be of any length, but it's a whole digit number. For your understanding sake, let's go back to data block. Inside a data block, we know that there is a Merkle root, which gets impacted when we make any change inside the data. Okay, so nothing can be done here. We have a hash address of the previous block, and it gets generated automatically. I have no control over it. Then there was a version, and there was a timestamp. Again, I have no control over it. And I also know that hash address of that particular data block uses the input of these four components. So what I do is, the only thing I'm left with is nonce. So I try to guess nonce, this whole digit number from 1 to 1 billion and 1 trillion, and try to see that which particular number will return me an hash address of that block, which will start from 4 zeros. Okay, so this is how this is the relation between nonce and difficulty target. I know right now it might be a little confusing, but as soon as we move to the demo, it will get much more clearer. So just for now, just understand that nonce is related to difficulty target, and you adjust the nonce to meet the conditions of difficulty target. Just keep this thing in mind, and let me take you to the demo. Okay, so starting with the basics, first let me just show you that how a hash function works. So I can give input of any type, and a random hash output is generated for me. So just notice that even if I make a slightest change of changing the capital letter from to a small caps, hash address completely changes. How sensitive of a change it is able to pick. Even if I add an extra space, hash address completely changes. So this is the sensitivity of an hash, or like or the hash function. So for this particular demo, we are using hash function SHA-256. This is what is used in most popular blockchains like Bitcoin also. Another thing that you need to know is that even without a data, a hash address can exist. So when a blockchain is newly created, when a block is newly created, it already has an address, it always has an hash. So this is how a hash function works. Now let's see how it works inside a block. Okay, now I told you there are actually, these are the components of a block. This is the sequence, like this is the first block. This is the nonce that we can control, that every peer in the data block has to guess. And this is the place where I enter my data. So let's just say I entered something into this block, and because of this, my hash address got impacted, because one of the out of one of the three inputs, I changed one, hash address has changed. So in order, which makes this block invalid. Now, why is this invalid? For this, okay. Notice here that in its original form, when there was no data in this data block, my difficulty target was that the hash address should always start with 4 zeros. Here, that condition is already being getting satisfied. But when I go and make a change in this data block by entering something into the data, my hash address has changed. And new hash address which is generated here does not satisfy the difficulty target. It does not suggest, it does not shows that the first 4 digits of this hash address is not starting with 4 zeros, which was my difficulty target. So now I try to guess. Now I cannot change the sequences this block. I can go and change this data to adjust the hash, but again it won't solve the problem. So what I can do is I will try to change the nonce. I will try to see which particular digit will give me a new hash address which is starting with 4 zeros. So like you can see here, what I'm doing, I'm trying to enter random numbers and see which one sticks. So you can do it manually. But if you're having a powerful computer, if you're having a supercomputer who can guess this number quickly and faster than other peers who are in this network, then you win. So let's assume I had that technology with me. So on a click of a button, I quickly guessed that for this particular nonce, I will get a hash address with 4 zeros. And that is how I satisfied or I validated this block. And this entire process is also called mining or data mining. Okay. Now let's see this thing inside a blockchain. Okay. Now you can see like there are 5 blocks with me. Each block is having its own hash address and hash address of its previous block. This hash address is generated using 4 inputs, that is the sequence number of that block, the nonce, the data that is stored in the block, and the previous hash address or the hash address of the previous block. Any change being done in any of these 4 components will change the hash of this hash address of this particular block. And unless and until the difficulty target, which is again the hash address will always start from 4 zeros, is being met, this block will remain invalid. And if it is invalid, that means it's not part of the blockchain. So let me again try to change the data inside this blockchain. And if you want, I can just change the nonce as well and the data as well. Either way, this particular block is invalid. Because this block is invalid, this block which was having the address of previous hash, like a hash address of previous block is also invalid. Similarly, all of them are invalid. So as a hacker, it becomes difficult for me. Okay, so let's assume that I hacked this particular second block of this blockchain, and I go about and I try to guess the nonce here. I did it fine. Then I'll go to the third block and I'll try to guess the nonce here. I get done. Okay, so I've validated this entire blockchain right now, but because this was just 5 blocks right now, I was able to do it so quickly. A realistic blockchain would have 1,000 and 10,000 of blocks in a series, which I will have to validate again after and again. The challenges there are so right now the most powerful computer is also able to guess a nonce, but it takes around 10 minutes to guess a nonce for 1 block. Imagine had to doing it for 10,000 blocks. It's 10 into 10,000. On top of that, other peers or other computers in the network would also be trying to do it at the same time. Similarly, at the same time, you will be getting a request to enter more and more data. So you, to keep yourself as a part of blockchain, you also have to satisfy those requests. So this is how, when the process gets complicated, it adds to the security of blockchain. Yeah, someone raised a
There's a question from Vijay that is nonce a control parameter?
yes.
And the next question is, what is the use of data mining? That is guessing the data in a block. Is that the only thing?
No, not guessing the data in a block. Data mining. Okay, so try to think of it in 2 ways. One is ethical, one is unethical. Ethical when someone, my owner or the owner of this blockchain asked me or asked everyone in the network to enter a record in this particular data block. Now everyone will try to in their copies, the copy of that blockchain that they have on their local system, they will make this update. Now what they have to do is they have to satisfy this data block as well, because right now it's invalid. For all of them, there is only one common difficulty target, that is the hash address should start from 4 zeros. So they will try to guess this particular nonce and satisfy it. Now condition on this one is that 50% of the people, 50% of the peers should come or should reach to a same nonce. Not like that I satisfied this data block using this nonce and another one find out Okay, it's not picking up. So, and another one, find out the next best number, which will next best nonce, which could be 1 lakh something, and which is giving me an hash address of that starts with 4 zeros. All of them needs to, at least 50% of them needs to arrive at the same nonce for everyone being able to enter this particular data in the blockchain. Vijay, there was a question.
Yeah, let me just, so Vijay has a question which he wants to ask directly. I'm allowing him to talk. Vijay, you can speak now. You can unmute him.
Yeah, thank you. My question was like with respect to the current example, like we have seen the rule, what we set as a hash is 4 zeros, right? And when we are trying to change the data, it's actually showing as invalidate with the color change. But in the first example, we showed that we can change the nonce to make the data as valid, just
Right.
to understand, right? Right. So that part is pretty much clear. Now, when we take this part of something like a chained data and we try to provide some data here with a nonce, it's invalidated. Even though you change the nonce also, it is actually showing invalid. So this is it is a little bit of ambiguity here, like how to understand or interpret here.
Okay, so actually, you as a hacker or even as a valid peer, you need not to change the nonce. You never change the nonce unless and until you have changed the data. So as a hacker, you will try to manipulate a transaction. Like, instead of saying that like, $10,000 were transferred, you will say $1 lakh were transferred. And after that, to make that change valid, you change the nonce. Like, the cause, then the effect. Otherwise, you never will go and change the nonce just for the sake of it. Because in any case, it's just making the block invalid and there is no purpose to it, no advantage to you for it. It was just for the sake of example, I changed the nonce. Otherwise, no one does it.
Okay, just to understand pretty much clearly is that the nonce and the hash gets created automatically, right, for each of the block, because here you are showing from the hacker's perspective, like if they try to hack, it gets invalidated. But generally, if you provide a data, the nonce get created automatically. Is that what we can interpret or comprehend from this example?
Yeah, so like I told you in like somewhere in the starting that there are criteria. So if you want to enter a Bitcoin blockchain, the most popular blockchain, you have to show that I have so much GB of RAM in my computer, and this is the processing power of my computer. So using these two things, you run an application that will try to guess this nonce. Okay, so nonce is not something that blockchain will guess on itself. This is something that you guess externally and then come and feed into it. Right now, the demonstration that we are using, makes it simple for us that just by the click of a button, we are trying to guess the nonce in the same block. But generally, it is done outside the blockchain, and then that number is bought inside the blockchain.
Okay, so here we are trying to say that we can edit the data. Is that what we have to take the
Correct.
Right? Okay. Okay, got it. Thank you.
There's one other question, which is from Vandana. So she's asking how condition for hash function gets decided. Like here we said that it starts with 4 zeros.
Oh, okay. So you mean difficulty target. So for the example's sake, I have decided a difficulty target that my hash address should start with 4 zeros. There can be any difficulty target, any sort of a puzzle that the owner of the blockchain can decide. And that can be from like one difficulty target is such 50% or 75% of the peers in a blockchain should arrive at same nonce in 2 minutes. If they are not able to arrive within 2 minutes, then that change will not stick. Then again an attempt will be made. So the cycle or the time period for entering that particular data is only for 2 minutes. That is the difficulty target. So likewise, any it's a basic simple puzzle. that you can utilize to protect your blockchain. Similarly, in private blockchains, they usually have a bag of difficulty targets, which is randomly picked by the computer and sent to all the peers. So it makes it more secure. Not every time you can use the same technology and use the same technology, same logic and satisfy the block. It changes every time it changes. It makes it harder and harder to get hacked or to change.
This one last question from Krishan. So basically mining is done guessing the nonce value. Right?
Correct. All right. Then let's have a much more realistic example of how blockchain works. Okay. So this is an example of distributed network. So for now, there is peer A, B, C. Okay. All of them are having exact same copy. Just noted that nonce is same for everyone. Hash address of previous and their block is same for everyone. So altogether, all the three peers have the exact same copy of this blockchain with them. Now, as a hacker, I come in and I hack the computer of peer A, and I go about and make a change in block 4. I just write my name in it. And as we know, this block becomes invalid because my difficulty target is not being met, not being satisfied. So I go about and mine the nonce. I find a new nonce and satisfy this data block. Then again, I go here, I mine the nonce for block number 5, and I satisfy this data block here. Now, right now, everything is looking green, right? No one will be able to tell from the first look that there is something wrong. But every blockchain has a periodic cycle, which is decided by the blockchain itself. Sometimes it's 1 week, sometimes it's 1 day. What it does, it compares the hash address of the last block in the blockchain. So in this case, we will compare the block address of block number 5. I'll see the hash address of this of peer B does not matches the hash address of peer A. Similarly, for peer C and peer B, there is a match. Again, for peer C and peer A, there is not a match. So when such cases happens, everyone will decide, or the system will automatically decide that peer A has been compromised, it has been impacted, and for a very temporary time or time period, peer A will be removed from the blockchain unless and until it regroups or re-identify itself with the live or the correct copy. It again has to go through the entire waiting list and the process of entering the blockchain again. And this is how blockchain is different from an SQL server. It is able to identify the change, resist it, and if it's not able to resist it, it is able to correct it. And basically, this is how the entire blockchain works, and the security of blockchain works. Okay. Okay, so Vignesh has a question. Since you have said buying a Bitcoin does not mean you are a peer, what is the benefit of becoming a peer? So benefit of becoming a peer is that instead of spending your money into buying a cryptocurrency, you earn it. So, okay, let's take a very live example here. Okay. This is a much more realistic representation of what a blockchain looks like. There are multiple requests of transaction records that needs to be added. Let's just assume there is a latest request where some Denise wants to, Denise transferred $14 to Edmund, and we want this record to be added into the block. Now, again, in our noise group, we will get a message that add this transaction in, add this transaction. And we all will try to enter this transaction into our local copies of blockchain. And then we will try to guess the nonce. Once we have guessed the nonce, will come back to the blockchain and we will tell the blockchain this is the nonce. The first one to guess it will wait for 2 minutes, 3 minutes, whatsoever time is there, till 50% of the peers in the blockchain has arrived at the same nonce. Once they have done, I win. Since I was the first one, I win. I get the right to make the change in the original, in the live copy of blockchain. And once that change has been done, I am being rewarded by the cryptocurrency, which in case of Bitcoin right now is 1 Bitcoin or half a Bitcoin for every time you make a change. And when I say change, you are basically mining the data block. Every time that you are guessing a nonce, whether ethically or unethically, you are doing the mining. You are doing data mining. So many times when you hear the term data mining, or when you hear the term that he's a miner or I'm doing mining, this is what they are trying to say. Yeah, no question. You must be a peer to guess the nonce, right? Yes. You won't even get the request to so if you are a peer, you get, first of all, get the request to make the change. You get the difficulty target. Not necessarily it is same every time. So unless and until you are not in the network, you won't be getting these two things. So I will be rewarded for guessing the nonce. Yes. Guessing the nonce first. It might seem right now simple that I need to just guess the nonce, but it is looking simple right now because our difficulty target is that simple. Usually difficulty targets are much more complicated than this. No, peers have the whole blockchain, but they have the local copy of it. Okay, so there is one live blockchain and every peer in that blockchain will have a copy of it for their own use, for their own experiments. But for them, they have to go and make a change in this live copy. And when this change is being done in this live copy, it gets broadcasted or transmitted to everyone's local copy. Shouldn't all transactions be recorded by default? Why will someone request to add a data to blockchain? So this happens in case of private network, private blockchains, where they have to request that please update this transaction. Generally, you can program a transaction to go via blockchain. It's not necessarily a request has to be made. And again, when you do that programming, you provide the program with a private key, and in other cases one particular person has that private key. So it's just the matter of automating the process. Okay, if no more questions, then I'll return back to the slide. So basically this is all there is in the basics of blockchain that you need to understand. Yeah, this we have already covered. So this is how generally the flow chart works. So someone makes a change request, the peers in the network verify the authenticity of that change using the combination of public key and private key. Then the blockchain who broadcasts the difficulty target or challenge to all the peers in the network, and whosoever guesses the nonce immediately tell it back to the blockchain. And once 50% of them has guessed the same nonce in the required amount of time, the blockchain gives the permission to update the hash code, or to make that change, enter the right nonce, and the hash code will get updated on itself. And then it gets the change sticks, live copy gets changed and it get transmitted to all the peers in the network. And this is just an example of how a transaction in a blockchain works. All right. Then in the last part, again, if this is shared with you, I have shared 3 more things with you. A blog on how the internal functions of blockchain work, everything that we have discussed so far, a video of how these things work, and again the tool that we were using right now to demo the internal functions of blockchain. I have given a link to it. You can use it and do it for yourself. All right, this is all there is to know about the basis of blockchain. From here, henceforth, I think once you have some understanding of how these transactions are working, you'll be able to guess at how exactly the cryptocurrency and NFT and this Ethereum is also working.
Awesome. Great. I think Kratitva, that was a great session. People, at least I got to know a lot about how blockchain works and how we are securing it. So thanks for the session, folks. If you do have any means, we will be sharing the feedback link with you now. I had shared it right now. So if you have any questions and any feedback for Kratitva, do share with us. And if you have anything specific for the sessions, do share with us. We'll try to enhance our sessions better. And thanks, Kratitva, again for this wonderful session. We'll share the slides with the attendees, and we have all. We'll share the YouTube link also with who couldn't attend. So that was a great session. Thanks, Kratitva.
Right.
Thank you very much. Thanks, folks, for joining in, and have a nice day. Please fill in the feedback if you can. That would be very helpful.